Lesson 8. Keeping components pure. Some JavaScript functions are pure. Pure functions only perform a calculation and nothing more. By strictly only writing your components as pure functions, you can avoid an entire class of baffling bugs and unpredictable behavior as your codebase grows. To get these benefits, though, there are a few rules you must follow. 1. Introduction. In JavaScript, some functions are known as pure functions. Pure functions simply perform a calculation and nothing more. When we apply this idea to React components, we gain a powerful advantage: predictability. By strictly keeping our components pure, we prevent an entire category of confusing bugs and unpredictable behavior as our applications grow. To fully enjoy these benefits, though, there are some essential rules we must follow. 2. Purity. Components as formulas. In computer science, and particularly in functional programming, a pure function has two main characteristics. First, it minds its own business. It doesn't modify any objects or variables that existed before it was called. Second, it's consistent. Given the same inputs, it will always produce the same output. Think of a math formula like y equals 2 times x. If x is 2, then y is always 4. If x is 3, y is always 6. It doesn't vary depending on the time of day or what's happening elsewhere. The same input always produces the same result. React is built around this exact idea. Every component you write in React is expected to behave as a pure function. That means that if you give a component the same inputs, in React terms, the same props, it should always return the same result, which in this case is its JSX output. You can imagine components as recipes. If you follow a recipe precisely and don't introduce new ingredients halfway through, you'll always get the same dish. The dish, in this analogy, is the JSX that your component produces for React to render. 3. Side effects, unintended consequences. React's rendering process depends on purity. A component should only return its JSX. It should not change or interfere with any existing data outside of itself. If a component starts altering variables that existed before rendering, it becomes impure. When that happens, React can no longer guarantee consistent output. Just as in mathematics, if your formula stops behaving predictably, your entire system loses stability. In programming, this leads to bugs that are hard to track down and behavior that changes unexpectedly depending on when or how often something is rendered. To fix this, instead of letting components modify outside data, we pass the data they need as props. That keeps every render self-contained and predictable. It's also important to understand that React doesn't guarantee the order in which components render. Each component should work independently, just like individual equations in a math test. One shouldn't depend on another to do its job. 4. Local mutation, your component's little secret. In the previous examples, the main problem was changing a variable that existed before the render. This kind of change is often called a mutation, and pure functions don't do it. They don't modify things that were created outside their scope. However, it's perfectly fine to modify something that your component creates during its own render. For example, if a component creates a new array or object within itself and then updates that array before returning its JSX, that's not a problem. That data didn't exist before the render, and nothing outside the component can access or depend on it. This is called a local mutation. It's the component's own little secret, and it doesn't break purity. 5. Where you can cause side effects. Even though we strive for purity, at some point our program must cause real-world changes. That's the whole point of programming. Updating the screen, playing an animation, or saving data are all examples of side effects, things that happen as a result of user actions or state changes. In React, side effects belong in event handlers. These are the functions that React runs when users interact with your app, for example, clicking a button. Event handlers are not part of the rendering process, so they don't need to be pure. In rare cases, you might need to run side effects after the component has rendered. For that, React provides a mechanism called useEffect. But this should always be your last resort. Whenever possible, try to express your logic using rendering alone. You'll be surprised how much you can achieve without stepping outside purity. 6. Recap. Let's review the key ideas. First, a component must be pure. It should not modify any existing data, and it must always return the same output for the same input. Second, rendering can happen at any time, so components must not depend on one another's rendering order. Third, you should never mutate the inputs your components use, whether that's props, state, or context. If you need to update something on the screen, use the proper way to set new state instead of mutating what already exists. And finally, aim to express as much of your logic as possible directly in your JSX. If you need to cause a change, use an event handler. Only as a last resort should you rely on side effects through useEffect. Writing pure components takes some practice, but once you get the hang of it, you unlock one of the greatest strengths of React: reliable, predictable, and maintainable code.